So hello and welcome to today's lesson. Today we're going to look at radioactivity, and we will start by defining what is radioactivity. So radioactivity is just a process where unstable nuclide disintegrates to a different nuclide, different in composition, with emission of a radiation and energy. We also have some terms that you need to know how to define them. One of it is radioactive, which is just a substance which undergo radioactivity, while radioisotope is an isotope which undergo also radioactivity. And then we have radioactive decay, is a spontaneous disintegration of a radioactive nuclide. Now let's look at types of reaction. We have a chemical reaction and a nuclear reaction. And so nuclear reaction takes place in the nucleus and involves protons and neutrons, while chemical reaction takes place in the outer energy levels and involves valency electrons. Okay. And then we also have point number 2, it releases large amount of energy for nuclear reaction, while for chemical reaction it releases much less energy. 3 is that it's not affected by environmental factors, while the other one, which is chemical reactions, is affected by environmental factors. Number 4 is that changes are irreversible, while some of the changes in chemical reactions are reversible. So there are two types of radioactivity, of natural and artificial, but we'll not dive much deeper into that. And we have types of radiation, which are 3. We have alpha, and then we have beta, and we have gamma radiations. So characteristics of radiation. As we said earlier, we have 3 types of radiation, alpha, beta, and gamma. So for alpha, they are positively charged and represented as shown here, helium, in actually a nuclear reaction. So what are the characteristics of radiation? Number 1 is that they are positively charged and are represented as shown here in a nuclear reaction. And 3 is that they're the heaviest of the 3 radiations. Okay. For beta particles, they are negatively charged and are represented as this. And there are streams of electron originating from a nucleus when a neutron changes into a proton. And then for gamma, so for gamma rays, they're high energy rays and they do not have electrical charge. Normally are not emitted alone, but they're accompanied by alpha and beta emissions or particles. So what are the properties of radiations? What are the properties of radiations? Number 1 is penetration power. So alpha particles have very low penetration power and can be blocked by a sheet of paper, while for beta particles have high penetration power and can pass through a sheet of paper but stopped by a sheet of aluminum foil. For gamma rays, very high penetration power, and so they pass through a sheet of paper and aluminum foil, but they are blocked by a thick lead block as shown here. So for here, this is alpha, this is so this is alpha, this is beta, and this is gamma. So for gamma are blocked by a lead block, but for beta are blocked by aluminum foil, and then for alpha they are blocked just by a sheet of paper. So for number 2, as a property of radiation, is that 1, for deflection by an electric field, that alpha particle being positively charged are are actually deflected towards the negative plate, and for beta particles being negatively charged are deflected towards the positive plate. Then for gamma rays have no charge, hence they are not deflected. So as shown here, you see in the electric field, alpha are deflected towards the negative because they are positively charged, while the beta particles are deflected toward the positively charged electric field because they are negatively charged, and gamma rays, they are not deflected because they don't have any charge. So lastly is ionizing power. Alpha particles have very high ionizing power. They readily ionize gases as they collide with them, and this is due to their slow speed and high charge. While for beta particles have low ionizing power, and while actually gamma rays have the lowest ionizing power. Okay, so that's what we have learned today, and I'll continue with part 2 section of radioactivity. And thank you so much for watching. See you in my next lesson.